Okay, so next question is 630. The whole bridge truss is subjected to the loading shown. Determine the force in members DE, EH, and HG and state if the members are in tension or compression. Now, we are asked for the forces in DE. So this is the member DE. EH, this one, and HG, this one. And we are asked for the members. The loading is given. There exists a 30 kilonewton load at point B. There exists a 20 kilonewton load at point C. There's another load 20 kilonewton at point D, and a 40 kilonewton load at point E. The system or the truss system is has a fixed support at A with pin. Certainly, it restricts the motion in horizontal and vertical direction. As a result, we have two reaction forces in horizontal and vertical direction. And certainly at point G, there is only one reaction forces, which is in vertical direction, because it can easily move in the vertical direction. Now, the distances are given as like this. Each member, horizontal or vertical member, has a length of 4 meters. So from there we can easily calculate the members, length of members AC, GD, or DH and EG. So we will use method of sections for solving this problem. In fact, it is better if we cut the structure from here. So we make a cut, and certainly we can take either side, either the left hand side or right hand side. Doesn't matter, both are the same. Now let's proceed. Of course, first step is to draw the free body diagram of the problem. So again, we choose the horizontal axis as X and vertical axis as Y. That's okay. So we have two coordinate system here, our coordinate system. Now at support A, we have FAX and FAY, and at G, we have only FGY. We will first calculate the support reactions. In fact, I will begin with the moment. I will take the moment with respect to A. This will, as a result, I will eliminate the forces at point A from the equation, and I will be left, I will have only FGY as an unknown. So FGY multiplied by 16 minus, because this minus 40 Newton load will generate a negative moment if FGY creates a positive, minus 40 multiplied by 12, distance to the point A is 12, minus 20 multiplied by 8, so it is the moment generated by this force, and then minus 20 multiplied by 4, it is the moment generated by this force, and this is equal to 0. Now from here we can easily calculate that 16 FGY is equal to 720 and FGY as 45 kilonewtons. Now next, sum of the forces in X direction is equal to 0. Obviously, we have only Fax in x direction. This basically means that Fax is equal to 0. Now, sum of the forces in y direction is equal to 0. Now, in y direction, we have Fay and Fgy in positive y direction. Minus 30, this one, minus 20, this one, minus 20, this one, and minus 40. And this has to be equal to 0. So remember that Fgy is equal to 45. And from there, we can easily calculate the Fay as 65 kilonewtons. Okay, now we have found the support reactions. In fact, we made the cut, and again, we can choose either side. I prefer to choose right-hand side for the calculation of the forces in members FDE, FEH, FHE, and FHG. Again, I put the forces. Fax is 0, remember that. So first, I take the moment with respect to h, because at point h, I have two forces. I have FHE and FHG. Now, taking the moment with respect to h, joint h, will eliminate the forces that act to this point, and I will be left with only FDE. Now, if I calculate the moment, and assuming that the counterclockwise direction is positive, Fay minus Fay multiplied by 12, this is the moment generated by this force. 30 multiplied by 12, this is the moment generated by this force, plus 20 multiplied by 8, it is the moment generated by this force, and 20 multiplied by 4, it is the moment generated by this 20 Newton load, and finally minus FDE multiplied by 4. So again, it is negative because FDE will try to rotate the structure in clockwise direction. From here, I can calculate the FDE. The value for the FDE will be then minus 45 kilonewtons. Okay, now I have found the force that comes to FDE. Now, since this left-hand side has to be in static equilibrium, I have two more equilibrium conditions. One is sum of the forces in x direction has to be equal to 0. FDE plus FHG, these are the only forces in x direction. It has to be equal to 0, and from there I can easily find the FHG. FHG is equal to minus FDE, and that's equal to 45 kilonewtons. Next, sum of the forces in y direction has to be equal to 0. In y direction, I have Fay minus 30, minus 20, minus 20, and plus FHE. This has to be equal to 0. From here, if I put the values into their places, so remember that Fay is equal to let me check the value. Fay is 65. That's okay. This is 65. And from here, FHE can be found as 5 kilonewtons. So I find all the forces that is asked to me Certainly, the positive values means that the member is under tension, and negative value means that it is under compression because of the choice of the forces.